Alright, so for this tutorial, we are going to be creating a butterfly plot in SAS. So I'm just going to make this full screen, give it a second, make this full screen as well, and I am going to be walking you through the code and also explaining what each line of code does. So the first thing we want to do is we want to set our working directory. So we do libname bp. My stuff is saved to my OneDrive because I'm using VLabs, and my folder is called programming, so mine is going to be O programming, and we do options fmt search equals bp. That first line of code you see there, that basically is just telling SAS where your folder is located on your computer or on your server, and that BP right there, that is a shortcut name, also called a library reference, and it is pointing us to the O programming folder. And now any data sets we have saved in this folder can be called up with using bp dot whatever the data set name is. And that options fmt search equals bp, that just tells SAS to look for any custom formats like value labels inside the bp library. And this way, if you create any formats, SAS knows where to find them. The next step you're going to want to do is you're going to import your NHANES dataset into your OneDrive folder where you will be keeping it if you haven't already. You can do that using a proc import. So that just is going to read the NHANES 17.dta stata file and bring it into SAS. And the data file equals, that just tells you where your SAS file is. And the out equals bp.nhanes17 saves this data set into your working library, which is bp, and names it nhanes17. That dbms equals dta just tells SAS that the file type's from stata, and that replace means overwrite the file if it already exists in the BP folder. So step one, we need to add some formats or value labels for our variables. For this tutorial, we are going to be using DUQ200, which is the variable for ever used marijuana or hashish, and our other variable is going to be reagender, which is the gender variable. So for this step, we use a proc format. You do proc format, value your DUQ200 format, 1 yes, 2 no, 7 refused, and 9 don't know. And then for the reagender, you're going to do 1 equals male and 2 equals female. This basically is just creating readable labels for your coded values as opposed to just putting numbers in your output. That proc format is what's going to start your process. That's basically our command. That DUQ200 underscore format, that just changes your 1s to yes, your 2s to no, 7 to refused, and 9 to don't know for the marijuana use question. That reagender underscore FMT, that's just changing 1s to male and 2 to female, and it's basically just, all this is just to make your output easier to understand instead of just seeing numbers. And you do want to make sure you do that because 1 isn't always going to mean yes, 2 is not always going to mean no. Refused and don't know, that's sometimes 77 or 999, so you always want to make sure you're checking your dataset codebook to get the right values to put in. Then for the next step, we are going to clean up our data. We don't want to include the refused and don't know responses. We want to leave them out of our graph or whatever analysis we're doing, so we're going to recode those. So for this, you're going to want to put data, marijuana. You can rename it whatever you want. I'm just choosing marijuana because that is what my main variable is about. set bp.nhane17, that's just basically taking the nhane17 data set and making a smaller data set from it, titling it marijuana. The next line, if DUQ200 in 7.9, then DUQ200 equals dot. That just says if it is equal to 7 or 9, which is refused or don't know, then it is now missing. Then you do the same thing for reagender. If reagender not in 1.2, then reagender equals missing. So that's just basically if you're not male or female in this data set, you don't have a value for that, then you are excluded. And then you need to apply your formats that you created earlier. If you don't do that, then you've basically just done this step for nothing. So format DUQ200, that DUQ200 format that you have from earlier, the reagender underscore format that you have from earlier, and then run. For step 3, you are going to want to generate frequency counts by gender and marijuana use. So you'd use a proc freq, data equals marijuana, no print. That no print is basically just, excuse me, sorry, I need some water. That no print basically just says don't put the table into a results window, you just want to save the output as data. And it is going to make that table, and then it's going to put out that new data as freak out. Get it? Like freak out. Going bananas, you know. I thought it was fun. Okay. But I digress. So then the next step is you want to transform that data even further to prepare it for your butterfly plot. So we're going to do data, plot data. So now we are making another tiny, even smaller data set called plot data. Set freak out, that just says take it from that freak out data set. Then to transform the data, you do if reagender equals 2, then count equals negative count. And what that is going to do is it makes it so that the values for female are negative so that they will appear on the left side of our graph. And then else count equals count, that keeps the values for males as positive so that they appear on the right side of our graph. And then you're going to run that. For step 5, we are actually going to create our butterfly plot. So first we do title, bold, and then whatever you want to name your plot. I'm naming mine butterfly plot of having ever used marijuana by gender, just to keep it simple. You're going to do a proc sg plot, data equals plot data. So that is going to, that command just basically says, hey, we're making some sort of plot with our data, and the data we are using is our plot data set that we had just created. H bar DUQ200, that is just telling us that we want it to be a horizontal type bar chart. The response equals count, that just tells us to use the number of people or the count for the length of the bars. Group reagender, that just creates separate bars for males and females. Group display equals cluster, that places the male and female bars side by side, butterfly style, because of those negative counts. And the data label, that just adds the numbers directly on the bars. Then you have x-axis label, number of respondents. It's going to label our x-axis as number of respondents. The values, negative 3,000 to 3,000 by 1,000. That just sets the range of your axis from negative 3,000 to 3,000 with tick marks at every 1,000 mark. The y-axis label, that just creates your labels for your y-axis. I'm doing ever used marijuana or hashish because I use the DUQ200 variable for this. The key legend / location equals inside. Position equals top right, across equals 1. That just puts the legend inside the plot at the top right corner, and it makes sure the legend shows the color for males and females. Now this last part here, style ATTRS, I'm not sure what that's supposed to be abbreviated for, but data colors equals, and then the two color codes, that just basically assigns dark green and then for males and then light green for females. I chose green, different shades of green, because it's a marijuana variable and the plant is green. But this command right here basically is just controlling for your bar colors, and then you just do the codes for those colors. You can look it up in different SAS documentations that are available online, and then you run that. So I have run this before just to make sure it works. So what you see when you recreate it might not be the exact same, but I'm first going to run this part to set my working directory. I check my log. It's all good. Also, I apologize. You may hear my dog start to bark in the background. Then we are going to run our proc import to import our data set. Let it run. So you can see in your log, you got to make sure you go back into your log to make sure everything's worked. Going to run my proc format to create my formats for my variables. Going to run it. Check my log. See that it worked. Go back. Prepare the data set, clean it up, run that part, hit run, check our log. Worked. Go back, run this part here for that proc freak. Run, log, it ran. Notice how it didn't give you that results window. That is because we put that no print. We want to transform our data for the butterfly plot next, so we're going to highlight our code. Going to run it. Check our log. Looks like it's worked. So we can go back, and finally we can create our butterfly plot, and it should give us our plot. Beautiful. Now, if you were to use a variable with more than two categories, for this, in this case, the marijuana variable, it's either yes or no. You either have or you haven't used it, and then male or female, it's just yes or no. If you had used a variable with more categories, you would have a lot more bars here, and you would see why it would be called a butterfly plot, because it looks a bit like a butterfly, very messed up butterfly. In this case, we have a rather sad inchworm if you turn to the side, but that is the code for how to do butterfly plots in SAS. Thank you for listening.